Network security technologies. Network security is a broad term that covers a multitude of technologies, devices, and processes. Today's network architecture is complex and is faced with a threat environment that is always changing and attackers that are always tailing to find and exploit vulnerabilities. These vulnerabilities can exist in a broad number of areas, including devices, data, applications, users, and locations. For this reason, there are many network security management tools and applications in use today. Firewall. Firewall technology evolved to protect the Internet from unauthorized users on the Internet. A firewall is a combination of hardware and software technology. The firewall enables the network administrator to centralize access control to the network. A firewall logs every packet that enters and leaves the network. Firewall provides several types of protection, including the following. Block unwanted traffic. Direct incoming traffic to more trustworthy internal nodes. Hide vulnerable nodes that cannot easily be secured from external threats. Log traffic to and from the network. Packet filtering is one of the simplest and primary means of achieving network firewalls. Filters are specialized components present in the firewall, which examines data passing in and out of the firewall. The incoming and outgoing firewall packets are compared against a standard set of rules for allowing them to pass through or be dropped. In most cases, the rule base, commonly known as the rule set, is predefined based on a variety of metrics. Rules can include source and destination IP addresses, source and destination port numbers, and protocols used. Packet filtering generally occurs at layer 3 of the OSI model and employs some of the following metrics to allow or deny packets through the firewall. The source IP address of the incoming packets. Normally, IP packets indicate where a particular packet originated. A packet's approval and denial could be based on the originating IP addresses. Many unauthorized sites can be blocked based on their IP addresses. In this way, irrelevant and unwanted packets can be curtailed from reaching legitimate hosts inside the network. For example, a significant amount of spam and unwanted advertisements are aimed at third-party businesses, causing wastage of bandwidth and computational resources. Packet filtering using source IP-based rule sets can effectively eliminate much of such unwanted messages. The source IP address of the incoming destination IP addresses are the intended location of the packet at the receiving end of a transmission. Unicast packets have a single destination IP address and are normally intended for a single machine. Multicast or broadcast packets have a range of destination IP addresses and normally are destined for multiple machines on the network. Rule sets can be devised to block traffic to a particular IP address on the network to lessen the load on the target machine. Such measures can also be used to block unauthorized access to highly confidential machines on internal networks. The type of Internet protocols that the packet may contain. Layer 2 and Layer 3 packets carry the type of protocol being used as part of their header structure, intended for appropriate handling at the destination machines. Filtering can be based on the protocol information that the packets carry. Though packet filtering is accomplished at the OSI model's Layer 3 and below, Layer 4 attributes, such as TCP requests, acknowledgement messages, sequence numbers, and destination ports, can be incorporated in devising the filters. Stateful packet inspection is a technology used by stateful firewalls to determine which packets to allow through the firewall. It works by examining the contents of a data packet and then comparing them against data pertaining to packets that have previously passed through the firewall. Stateful packet filtering keeps track of all connections on the network, making sure they are all legitimate. Network-based static packet filtering also examines network connections, but only as they come in, focusing on the data in the packet's headers. This data provides less information to the firewall, limiting it to where it came from and where it is going. A DMZ, short for Demilitarized Zone, is a network, physical or logical, used to connect hosts that provide an interface to an untrusted external network, usually the Internet, while keeping the internal, private network, usually the corporate network, separated and isolated from the external network. as systems that are most vulnerable to attack are those that provide services to users outside of the local area network, such as email, web and domain name system, DNS, servers. They are quarantined inside a DMZ, from where they have limited access to the private network. Hosts in the DMZ can communicate with both the internal and external networks, but communications with internal network hosts are tightly restricted. The DMZ is isolated using a security gateway firewall to filter traffic between the DMZ and the private network. The DMZ itself also has a security gateway in front of it to filter incoming traffic from the external network.